Okay, let's look at some applications of some sinusoidal functions. So we have a carnival Ferris wheel. It has a radius of 7 meters and one complete rotation every 16 seconds. And the bottom of the wheel is 1 meter above the ground. So they want to know, what would the maximum value be? How tall would it be? So if I think about this, the radius is 7 meters, which means that the diameter has to be 14 meters. If we start 1 meter above the ground, that means that the maximum value has to be 15. So I can say, therefore, the max value is 15 meters. And the minimum value they gave me. Therefore, the min value is 1 meter. It wants to know the amplitude of the function. So the amplitude is the maximum minus the minimum divided by 2, or 7 meters, which I knew because they gave me the radius. They want to know what the period of the function is. That was given in the original question. So therefore, the period is 16 seconds. It wants me to graph the function. So I'm actually going to go and skip along a little bit to the equation part before I graph it. So I already know the amplitude, but I want to find the k value. So the k value is the maximum plus the minimum divided by 2, which is 8 meters. I can also find the b value. So I have 16 is equal to 360 divided by b. I'm going to rearrange for b. And I get b is equal to 22.5. I'm going to come back and finish this question after I draw it. So I'm going to draw the graph. So this is my time in seconds, and this will be my height in meters. So I have to get to at least 15 meters. I'm going to go by 2s and see if that works. So 2, 4. And I'm good. I have enough space in my graph. My rotation is every 16 seconds. So I'm going to do 2, 4, 6, 8, 2, 4, 6, 16, and I'm going to go like that. I also need to complete 3 cycles. That's what it's asked for. Mostly because if I did a different scale, I wouldn't fit it in. So it also tells me that I have to start at the lowest point. So I'm going to start at 1 meter, and 16 seconds later, I'm going to be at 1 meter again. Which means halfway, I'm going to be at the tallest point, which we know now is 15 meters. My k value was 8. I'm going to put that in on my graph because it'll help me locate my midline and the points on it. So that means halfway between this minimum and this maximum, I should have a point on the midline. Same thing on here, I should have a point on the midline. And I can create the first cycle. Now I'm going to pattern that out. 16 seconds later, I'm going to have a low point. 16 seconds later, I'm going to have another low point. Between these two, I'll have a high point. And between these two, I'll also have a high point. Halfway between here and here will be on the midline. Same thing over here. Halfway between here and here, I'll be on the midline. Halfway on the midline and halfway on the midline. And now I can connect the rest of the points to draw the other two cycles. Okay, so if I look at that graph, it's really a cosine graph with a vertical reflection. So that's probably the equation that I'm going to do. So I'm going to say that there is no phase shift. I'm going to come back here and I'm going to finish this one. And I'm going to say that for phase shift, we're going to say none. And I'm going to put in the vertical reflection, which makes it a little bit easier. My amplitude was 7. I've decided on a cos graph. You could do a sine graph with a phase shift of 4, but that's up to you. My B value is 22.5. I've decided on no phase shift, and I'm going to pick +8. Okay, so now I can use that equation to answer the next two. So I want to look at it at 5 seconds, and then again at 40 seconds. What would the height be? So what I'm going to do is I'm going to take my equation. I'm going to say y is equal to -7 cos 22.5. I'm going to plug in 5 for x. I'm going to add 8. So I'm going to simplify on the inside here. I get 112.5. I'm going to add 8. And then I'm going to evaluate. So I'm going to say, well, -7 cos bracket. And then I'm going to do 112.5 close bracket. And then I'm going to add 8. And I get 10.68 approximately. And I can kind of look and verify that. So we wanted it at 5 seconds. So there's 2, 4, here's 5. And if we look, we're just below 11. So we're about right. So that seems like a reasonable answer. Okay, let's try for 40 seconds. So I'm going to take 22.5 and multiply it by 40 and add 8. This becomes 900. And I'm going to grab my calculator and evaluate. So I have minus cos of 900. I'm going to add 8. And I get 15 meters. And again, this is a value we can absolutely verify. And if we look at 40, it is 15.